Welcome to our video lesson on writing equivalent expressions and combining like terms. Before we start, across the top of your guided note, I want you to write this down. Combine, another way to talk about combine is put together. Like is just a way to say same. And terms can kind of be like things. So what we're doing in this lesson is putting together things that are the same. The first thing I want you to do is sort the following into two groups. So we have a whole bunch of shapes here, and on your guided note you have a table. You're going to draw these into the two groups so they match. Press pause until you've finished it. Hopefully your table looks something like this, where you have all the red ones together and all the yellow ones together. What we did was we combined the like terms, and we can do the same thing with expressions. So here's an expression, 2x plus 3 plus 2x plus 2. What I've done is I used different color of blocks to represent the different terms in our expression. So anyone with an x was matched up with the red shapes. Then anyone that didn't have an x was lined up with the yellow shapes. The reason they're different is because they represent different things. You can't combine 2x and 3 because the 3 doesn't have the x in it. It needs to have the x. But what we can do is combine the 2 x's and the 3 and the 2. How I'm going to write this is 2x plus 2x plus 3 plus 2. And then we're going to simplify this, or combine the like terms. If we put these two x's together, we would have 4 x's, or 4, 1, 2, 3, 4 red shapes. So we have 4x, and then we have over here we have 1, 2, 3, 4, 5 just numbers, and so that would give me 5. On your note, you see this. We have 4x, 1, 2, 3, 4, plus 5. All right, we're going to think about another situation here. We need to figure out how many cookies in total we have. Just look at the first half. Here we have 3 boxes of cookies. Here we have 4 individual cookies, and here we have 1, 2, 3, 4, 5 boxes of cookies. I'm going to write this problem as an algebraic expression. That would be 3b, because we have 3 boxes, and we don't know how many cookies are in a box. So depending on the number of cookies in the box, what b would be. So we have 3b, and then 1, 2, 3, 4 cookies. So I'm going to say 4 individual. And then we have 1, 2, 3, 4, 5. So 5 times b, however many cookies are in the box. And we're going to add them all together. So we have 3b plus 4 plus 5b. Now, we can't add 4 and 3b because they're different units, right? It won't tell us the number of cookies we have in total unless we add boxes with boxes and individuals separately. So we're going to rearrange it using our commutative property of addition so that we have 5b plus our 3b plus 4. Now to simplify this, we're going to combine our like terms. Our like terms are the boxes, and then separate would be the cookies. So combined it would be 5b plus 3b plus 4. So that is equal to 5 plus 3 is 8 boxes plus 4. And if you look at the situation, we have 1, 2, 3, 4, 5, 6, 7, 8 boxes in total plus 4 cookies. On your sheet, it's written as number 2. Can you make sure you've got all this written down under number 2? There's no picture. Okay, let's go over some key terms. The first thing you already know. This whole big circle here is called an algebraic expression. The next thing is inside here. Here are the new things. A term is a number, variable, or the product of a number and variable in an algebraic expression. Terms are separated by addition or subtraction signs. So this 2x is a term. 8 is also a term. X is also a term, and 5 is a term as well. Those are the terms of this algebraic expression. The next thing is called a coefficient. A coefficient is a number before a variable in an algebraic expression. 2 in this situation is a coefficient. So we have another example of a coefficient. There's no more in here. Well, if there's no number in front of a variable, its coefficient is automatically 1. So for this term, x, its coefficient is 1. Some more examples of coefficients would be if we have 12b, the coefficient is 12. So please make sure you have your definitions written out and the terms and coefficients and algebraic expression labeled. Now we're going to do some more examples. It says simplify each expression by combining like terms. The first one is 5 plus x plus 2x plus 8. I've done a little diagram underneath here to help you with this. The 5 and 8 are individual units. So we have 5 as an individual and 8 as an individual. Then x's are together as well. So I've got it drawn down here, and we're going to use first the commutative property. So we're going to rearrange it so we have like terms together. So that means we're going to have, I'm going to move this 5 to the end. So I'm going to rewrite it as x plus 2x plus 5 plus 8. Now remember, when you just have a variable, the coefficient in front of it is 1. So we have 1x here, and then 2 more x's. 1x plus 2x is 3x, plus 5 plus 8. Now we're not done yet because we still have more like terms. 3x is complete, but then we need to add 5 and 8. So we'll have 3x plus 13. And that is our expression simplified. The next one is with subtraction, and we're using the variable b. We don't have any just numbers or anything else in this expression except for our b's. So all we need to do is subtract our coefficients. What's 3? 3 minus 2. That'll give us 1b, which is the same as just writing b. Let's do some more. Let's do c together. 9k minus k plus 3 minus 2. We're going to start by highlighting the things that go together. All the k's will go together. And then just our numbers will go together. So we're going to have 9k minus k, and remember the coefficient here is 1. So 9 minus 1 is 8k, plus 3 minus 2 is 1. And that's that expression simplified. Try the next one on your own. Press pause. And then when you're finished, press play again. All right. Welcome back. I hope it went well. Hopefully, you saw that they're all x's, so we can actually color or paint them all the same color. I'm just going to do it one at a time. What's x plus 3x? Remember your coefficient here is 1. That's 4x plus x minus 2x, okay? 4x plus 1x is 5x minus 2x. So 5 minus 2 gives 3x. Hopefully you got 3x when you did this. The next question, this 5 shouldn't be here, this 5 should be over here. This next one, we have x squared plus 3x squared minus 2x squared. Okay, the x squared hopefully doesn't throw you off because you need to notice that they're all the same. They're all x squared. So we can treat them just like normal. In front of this x squared is a 1, the coefficient. So we have 1 plus 3. 1 plus 3 is 4. So we have 4x squared minus 2x squared. Okay, now we have 4x squared minus 2x squared. 4 minus 2 gives us 2x squared. And that's our answer for this one. All right, F should look familiar and be pretty great. Our like terms are all numbers here. Save the easiest one for last. What I'm actually going to do is rewrite this using the commutative property of addition to make it easier to do. So I'm going to switch these two. So I have 1 plus 39 plus 10 plus 5. You don't have to do this, but this is what I would do. Then we have 40 plus 15, which I can do in my head, and that's 55. All right, team, that's all for now, and you're going to do some practice problems to make sure you understand it. I'll see you soon.